Okay, we're going to talk about some real places on the Earth that are examples of the different kinds of plate boundaries. Okay, and this illustration right here shows different plate boundaries all in one picture. Of course, they never happen this close together. It's just an illustration, but it kind of helps you see the different kind of plate boundaries, and we're going to look at each part of it. Okay, the first part we're going to talk about is a convergent boundary with subduction forming an island arc. Okay, this is way on the left side of your picture. All right, what you see here is two oceanic plates converging. They're both oceanic. Even if they're both oceanic, one of them is going to subduct under the other one. One of them is going to be a little more dense, and so it's going to get subducted. All right, when it does subduct, the subducting plate gets pushed into the mantle and it starts to melt to form magma. Okay, and then that forms volcanoes on the ocean floor. And if those volcanoes get big enough, they form islands. It's called an island arc because it's usually a string of islands that are kind of curved. All right. It also forms a trench, and you can see right here where the subduction zone is, there's a deep trench where one plate is getting subducted under the other one. And so you've got a trench and then an arc of islands that are all volcanoes. All right, and that happens where you have a convergent boundary with subduction on an island arc. Okay, here's an example of an island arc where subduction is occurring. These are the Aleutian Islands, and they're part of Alaska. You can see this is Alaska up here. This is Russia. Okay, and Japan is way down here, and this is the Pacific Ocean. All right, the Aleutian Islands are a volcanic island arc, and the reason why they're an arc, you see how it makes a curve? That's called an arc. All of these islands right here are all volcanoes. All the way up into Alaska itself, there's volcanoes. They're all part of this island arc. All right, the Pacific plate down here is converging with the North American plate up here. So they are converging together. Subduction occurs. All right, since right here they're both oceanic crust, you see this trench that forms in the ocean right here. And then this one, the Pacific plate, is obviously more dense than the North American plate because it's getting subducted under, and as it melts, these volcanoes form, and it forms an arc of islands. This is called the Aleutian Islands in Alaska. All right. Now let's talk about, in the middle of your picture is a divergent boundary at a mid-ocean ridge. Okay, and you can see right here the two oceanic plates diverging. Magma rises to fill the gap, and new crust is formed. All right, and then these are some pictures from an actual mid-ocean ridge. This you can see are volcanic vents where volcanic ash and chemicals are coming out from the magma that's rising. And here, this is near the island of Iceland. You can actually dive and you can see the mid-ocean ridge under the water. There's no active volcanoes right here, but you can see the split in the earth that is the mid-ocean ridge. All right. And here's some pictures. This is Iceland, and you can see Iceland on this map. It's way up here by Greenland, all right, between, like Canada and Europe. And the mid-Atlantic ridge goes right through the middle of the island, all right, and there's all these volcanoes because of it. And here you can see all of the mid-ocean ridges on the different parts of the earth, okay? Just about all the oceans have them. All right. Next, we're going to talk about a convergent boundary with oceanic and continental crust. All right, here's the oceanic crust. Here's the continental crust. All right, we already know that the oceanic crust is going to subduct because oceanic crust is more dense than continental crust. All right, when it subducts, it forms a trench. And this is the long little hole where the oceanic crust is getting subducted. It makes a very deep trench in the ocean. All right, and then the subducting plate melts, which forms magma, and then the magma rises and it forms volcanoes on the continent near where the subduction is happening. Okay, so all these mountains right here are volcanoes that are formed from the magma rising from the subducting plate. All right, now where does this happen on Earth? Well, it happens in the Pacific Northwest of the United States. Okay, right here, this is Washington State, this is Oregon, and this is the top part of California, the northern part. Okay, there's a plate offshore called the Juan de Fuca plate. It is converging with the North American plate this way, and it's being subducted under. And as it subducts under, it melts and it forms all these volcanoes. All right, here's a kind of a side view of it from the side. If you were looking at it from the side, there's the Juan de Fuca plate. It's getting subducted under the North American plate. It's melting and forming volcanoes. All right. You can also have very large earthquakes at a subducting zone like this. It's not as often that you have earthquakes as you do with the transform boundary, but when they do occur, they're usually very strong, and since one of the plates is usually under an ocean, it can form a tsunami. All right, and then we have some pictures here of actual volcanoes from this area. This one right here is Mount St. Helens when it erupted in 1980. Mount St. Helens is this one right here in Washington. Okay, that was a huge explosion. It, you know, a lot of times when volcanoes erupt, they don't actually spew out lava. They spew out ash, which is little tiny particles of already cooled lava, and that's what this is. And then this right here is a picture of Mount Rainier, and Mount Rainier is just outside of the city of Seattle. So you can see here as part of the city of Seattle, these buildings, and that's Mount Rainier in the background. Okay, they're that close to a volcano, and it hasn't erupted in many hundreds of years, but of course it is an active volcano and it could erupt. All right. Next, we're going to talk about a divergent boundary that's a rift valley. Okay, in your picture way on the right hand side, you can see this is all continental crust. It is diverging. When it diverges, magma rises, forms volcanoes, and then it also forms this rift valley. You can actually see where the earth is being ripped apart. All right, where does this happen on Earth? The best example is the Great Rift Valley in Africa. Right here, these plates are separating, and all these volcanoes around here are the result of this Rift Valley and the divergent boundary. The most famous one is Mount Kilimanjaro right here in Africa. It's actually the highest mountain in Africa. You can see, even though it's in Africa, it's so high that it can have snow on it. All right, and this is a divergent boundary on land. All right, one more thing we need to talk about are hot spots, which are just holes in the crust. Okay, if you look in the middle of your map, you can see that there's it's what's called a hot spot, and it's just a hole in the crust, and it forms a volcano. It's called a shield volcano. And if it's underwater, well, if it gets large enough with enough lava coming out and forming new crust, it'll form an island. Okay, hot spots are not near plate boundaries. Okay, Hawaii's in the middle of the Pacific Ocean. It's not even close to a plate boundary. All right, here's a picture of the islands of Hawaii. Each one of those are volcanoes. The only one that's still active is the actual island of Hawaii, the Big Island right here. And this is a picture of it. You can see that there's actually more than one volcano on the island of Hawaii, and it's still active, and it erupts all the time, and its lava is forming new crust.